Hey everyone, just got a quick little video today. As you can see on the scope, I've got a roughly 1.1 megahertz, 20 volts peak sine signal. Very nice clean sine wave. A little bit of ghosting effect there from the intensity. Nice and clean though. We're at about 10 volts for division and half a microsecond for division. So right around 1.1 megahertz. It's 1.090 or so. And this is coming from a very small Colpitts oscillator that I whipped up. Just needed a reliable, stable signal source. All discrete stuff, all parts I pulled out of various toss-away equipment and whatnot. I think the only thing brand new on there is I think one capacitor and the LM7812, just an input regulator. But an interesting thing I did with that is I didn't have the main inductor I needed for it. Didn't have a 3.3 microhenry. So I made one because I got plenty of these little plastic bobbins around, and it's only a couple of turns for air core. Now, an interesting effect of having an air core inductor in your tank is that there's no core, essentially, to suck up and restrain the magnetic field. So the magnetic field lines can extend far out from the actual inductor. And we can take advantage of this here. I've got a little red LED, an inductor. That's it. It's a 250 microhenry inductor that I've kind of relegated for junk bin, nothing important use, because I actually used it on high voltage at one point, and you can see a little black spot there. It did short out some of the windings. Not a big deal for low voltage stuff, but for anything over about 20 volts or so, it does short out, just because there's internal carbon tracking there. So anyway, what we can see here, if I can get it on frame, is wireless transmission of power. Now, this is not through the E field, this is just through the H field, the magnetic field. But you can see how far out those magnetic lines really extend. It's quite remarkable. And of course, on axis is a lot better than off-axis, though there still is a fair amount of off-axis here, mostly because I think it's picking up from my output transformer there. Trying to tap it just off of a capacitor tap from the collector didn't seem to do a whole lot as far as keeping the sine signal clean. There was a bit of little wiggle, so having an impedance-matched output transformer here really does fix that, and allows a nice tap-off for a clean sine signal. But because I have them at 90-degree increments, you've got your main tank here, inductor, with a gigantic magnetic field from it. You can see quite a bit here. This is, of course, half-wave rectification, so you're looking at very much reduced brightness from that. And as it turns out, this inductor is self-resonant somewhere around 1.3 megahertz, and then the capacitance from the junction of the LED drops it down to, I think, somewhere around 1.2, 1.15, somewhere in there, which is close enough to the 1.1 that our oscillator is running. But anyway, because of that, you have on-axis and off-axis from the now axis of that output transformer. So not only can I tap off a main signal here, I can also tap it off wirelessly as I drop my little receiver. It's only drawing 30 milliamps, and input voltage is anything above the 7812's input, so 12 volts or higher, though it will oscillate down as far as 7 volts. I think that's mostly just the limitation of the 7812's passing, but it works good, and it is bright as hell, as you can tell. There's a fair amount of current coming through that, despite only 30 milliamps circulating. And of course, tapping off this way just sucks energy out of the tank without affecting the signal purity at all. I've removed it and put it away, and you can see no amplitude change of any measurable amplitude. And of course, no distortion. So that's it, just a quick little video. Useful oscillator for when you need it. It's right around the upper end of when I do some testing for GTTs and things like that, and having a nice sine signal helps when I need something pure that I'm testing for bandwidth. That's all. Have a good one. Oh, and a little teaser for the upcoming future. Some of you may know what this is. Yeah, that's coming. Stay tuned.